Example 1. Graph y equals the absolute value of x plus 1 using the plotting points method. To begin, we start with a table with 3 columns. The first column is titled x, second column is y equals, and then the third column is the ordered pair x comma y. And since y equals absolute value of x plus 1, I'm going to further fill in the second column heading with y equals the absolute value of x plus 1. So now I'm going to come up with a list of x values that I will put into the first column, and then I'll plug them into the equation in the second column to generate a y value, and that will give me an ordered pair for the third column. So when we generate x's for the first column, we want something negative, something positive, and 0. So we can do 2, 1, 0, -1, and -2. Positive, 0, and then negatives. So when x equals positive 2, y equals the absolute value of 2 plus 1, which equals 2 plus 1, which equals 3. Therefore, when x is 2, y equals 3. So I have the ordered pair 2, 3. I'm going to do the same thing when x equals 1. When x equals 1, y equals the absolute value of 1 plus 1, which is 1 plus 1, which is 2. So when x is 1, y is 2. Same thing now for when x equals 0. When y equals the absolute value of 0 plus 1, when x is 0, then y equals the absolute value of 0 plus 1. The absolute value of 0 is just 0, so that gives me 0 plus 1, which is 1. That generates the ordered pair 0, 1. Same thing for when x equals -1. When x equals -1, y equals the absolute value of -1 plus 1, which is 1 plus 1, which is 2. So when x equals -1, y equals 2. Same thing for when x equals -2. When x equals -2, y equals the absolute value of -2 plus 1, which is 2 plus 1, which equals 3. That gives us the ordered pair -2, 3. So we just generated a list of ordered pairs, and now we're going to plot those ordered pairs on a Cartesian coordinate system and then draw a line or a curve through those points. So the first point is 2, 3, so that's right 2, up 3. The second point is 1, 2, so that's over 1, up 2. The third point is 0, 1, that's over 0, up 1. Fourth point is -1, 2, so that's left 1, up 2. And the third point is -2, up 3, so that's left 2, up 3. So the points look like a V, and that is actually what the graph of an absolute value looks like. This one is just shifted up 1. So that is the graph of y equals the absolute value of x plus 1. Example 2. Graph y equals 1/2 x minus 2 using the plotting points method. We start with a table with 3 columns. The first column is titled x, the second column is y equals, and then the third column is an ordered pair x, y. And in the second column, I'm going to further update it by writing in y equals 1/2 x minus 2. So we're going to grab some x values, something negative, something positive, and 0. So we can do 2 as the first x value. So if x is 2, then let's calculate y. So y equals 1/2 times 2 minus 2. So I do multiplication first, so I need to multiply the 1/2 times the 2. If it helps, you can write that 2 over 1. So now I'm multiplying two fractions, 1/2 times 2 over 1. When we multiply fractions, we multiply straight across in the numerators and straight across in the denominators. So in the numerator, we have 1 times 2, which is 2, and in the denominator, we have 2 times 1, which is 2. So 1/2 times 2 equals 2 over 2, and then minus 2 from the equation. Well, 2 divided by 2 is 1, so that simplifies to 1 minus 2, which is negative 1. Therefore, when x is 2, y equals negative 1. Now let's do the same thing for when x equals 1. So when x equals 1, y equals 1/2 times 1 minus 2. Well, anything times 1, it's just itself, so that simplifies to 1/2 minus 2. Notice that I'm keeping my fractions vertical. That will help when you work with fractions. So I need to simplify 1/2 minus 2. If it helps, you can write the 2 over 1. So I have 1/2 minus 2 divided by 1. Whenever you add or subtract fractions, you have to have common denominators, which I don't. So I want to turn that 1 in the denominator into a 2, and I'll do that by multiplying it by 2, but not for free. If I multiply the bottom of a fraction by 2, I have to multiply the top of that same fraction also by 2. So that first fraction stays the same, 1/2, and then I minus the second fraction becomes 4 divided by 2, which makes sense because 4 divided by 2 is 2. So I now have common denominators, so I write the denominator once, and then I can combine the numerators. So I have 1 minus 4 in the numerator, that gives me negative 3 in the numerator. So when x is 1, y equals negative 3/2. All right, let's do the same thing for when x equals 0. When x equals 0, y equals 1/2 times 0 minus 2. Well, anything times 0 is just 0, so that gives me 0 minus 2, which is negative 2. So when x is 0, y equals negative 2. Same thing. Now let's go into our negative values of x. We'll start with negative 1. So when x is negative 1, y equals 1/2 times negative 1 minus 2. Well, 1/2 times negative 1 is negative 1/2, and from the equation I have a minus 2. So now it might help to write that 2 over 1. So now I have negative 1/2 minus 2 over 1. In order to add or subtract fractions, you have to have common denominators. So I'm going to turn this 1, which I don't have, so I'm going to turn this 1 in the denominator into a 2 by multiplying it by 2, but not for free. I also have to multiply the numerator by 2. So that gives me the negative 1/2 that was already there, minus the 4 in the numerator and the 2 in the denominator. So I now have common denominators. I have negative 1/2 minus 4/2. So I write the denominator once, which is 2. And then in the numerator, I have negative 1 minus 4. Negative 1 minus 4 is negative 5 in the numerator. So when x is negative 1, y is negative 5/2. And finally, we'll do the same thing for when x equals negative 2. When x equals negative 2, y equals 1/2 times negative 2 minus 2. So it might help some of you to write that negative 2, the negative 2 that's being multiplied by the 1/2, divided by 1. So I now have 1/2 times negative 2 divided by 1. So now I'm multiplying two fractions, and when we multiply fractions, we multiply the numerators straight across and the denominators straight across. So that means in the numerators, 1 times negative 2 is negative 2, and in the denominators, I have 2 times 1, which is just 2. And then from the equation, I have minus 2. So that gives me negative 2 divided by 2 minus 2. Well, I can clean that up because negative 2 divided by 2 is negative 1 minus 2 from the equation. So I have negative 1 minus 2 now. So negative 1 minus 2 is negative 3. So that means when x is negative 2, y is negative 3. That generates a list of ordered pairs, which I can now graph on a Cartesian coordinate system and then draw a curve through them. So the first ordered pair is 2, 1, 2, negative 1. So that's right 2, down 1. Second ordered pair is 1, negative 3 halves. So that's right 1 down 1.5. Third ordered pair is 0, negative 2, so that's over 0 down 2. And fourth point is negative 1, negative 5 halves, so that's left 1 down 2.5. And then the last point is negative 2, negative 3, which is left 2 down 3. So when I graphed all these points, it looks, I forgot the second one, the second point, which is 1, negative 3 halves. So that's over 1 down 1.5. Or maybe my computer just erased it accidentally. But when I look at those points, I can see that they are a straight line. So I'm going to draw a line through those points. And that is the graph of y equals 1/2 x minus 2. And we graphed it using the plotting points method. Intercepts. So if I draw an xy Cartesian coordinate system, and I'm just going to randomly draw a function on here. Okay, so there's a function, there's a graph, and x-intercepts are where the graph crosses through the x-axis. So on the graph that I just drew, it looks like there are 1, 2, 3, 4, 5 x-intercepts, because the graph crosses through the x-axis 5 times. Now I haven't labeled the x-axis, but the first x-intercept on the left, I don't know, maybe it's negative 10 up 0, the ordered pair negative 10 up 0, and then the second x-intercept is maybe negative 8 up 0, and the third one is negative 1 up 0, and then the fourth one looks like maybe positive 1 up 0, and then that last one maybe looks like over 6 up 0, so positive 6 up 0. Either way, all of those x-intercepts have one thing in common, and what they have in common is that the y-coordinate equals 0. So that's sort of a key idea here, is that when we're talking about x-intercepts, the y-coordinate is 0. So if I look at, so that means that any ordered pair that is an x-intercept must be something comma 0 to be a y-intercept. Okay, so let's do the same thing, but let's take a, so I'm going to get a different, an additional Cartesian coordinate grid. There we go. And I'm going to draw another function, and there's a function, and let's look at the y-intercepts. So the y-intercept is where the graph crosses through the y-axis, and I see that this only happens once. So maybe let me draw another graph on there, and again, this graph that I just randomly drew only has one y-intercept as well, but let's look at both of those y-intercepts. The first y-intercept, it looks like it might be over 0 down 2 maybe. If that's the case, then the second y-intercept, the y-intercept for the second graph that I drew might be over 0 up 4 maybe. Either way, what both of those points have in common, so those were y-intercepts, and what they both have in common is that the x-coordinate is 0. So any y-intercept written as an ordered pair will be 0 comma something. So therefore, to find the x-intercept, we always let y equal 0 and find x, but that's why we let y equal 0. And to find the y-intercept, we let x equal 0 and find y, and that's why we let x equal 0. Example 3. Find the x and y intercepts of the given graph. Write them as an ordered pair. Part A. This is a concave down parabola. I see that it intersects the x-axis at 1 and 3. Therefore, its x-intercepts written as an ordered pair are 1, 0, and 3, 0. The y-axis, I see that the parabola intersects the y-axis at -3. So as an ordered pair, that's 0, -3. Part B. This is a circle centered at the origin with a radius of 2 units. The x-intercept, there's 2 of them. They occur at -2 and +2. So written as an ordered pair, that would be 2, 0 and -2, 0. The y-intercepts, there's 2 of them, and they are -2 and 2, so they're the same numbers, but written as an ordered pair, they're different. As an ordered pair, the y-intercepts are 0, 2, and 0, -2. Part C. This is a concave up parabola. It does not intersect the x-axis, therefore it does not have any x-intercept. So for x-intercept we say there are none. The y-intercept, I see it intersects the y-axis once, therefore the y-intercept written as an ordered pair is 0 up 1, 2, 3, 4, 5. So 0, 5.